So today we're going to be looking at what happens when we divide exponents. Again, we have the b as our base and the n as our exponent. And as we talked about when we multiplied exponents, it's all about the base. Our bases always have to be exactly the same. But before we do that, how does it actually look like when we divide exponents? Well, division is another way that we can actually look at having fractions written down. So I want to look at what happens when we reduce a fraction. We take this and when we reduce a fraction, we break it down into its factors. So, for instance, 15 is 5 times 3, and then 10 is 5 times 2. When we go ahead and reduce a fraction, we find common factors, in this case 5s, and we cancel them out. And so I just happen to be left with our 3 over 2. So we're going to be doing the same thing when we divide exponents. So as I look here, I have b to the 6th divided by b to the 4th. Now, what does that actually mean? Well, when I look at b to the 6th, I've got the letter b written down 6 times, and they're all being multiplied. And so when I have b to the 4th, I also happen to have b written down 4 times, and it's also being multiplied. So I can cancel them out because I have a b on the top and a b on the bottom. Just like we had earlier when we actually had the 5s, I can cancel the 5s out. But here I'm canceling the b's out. So I can actually cancel another set of b's and another set of b's and another. So now I'm just left with my base of b and 2 of those. Of course, when we look at this and we ask ourselves, well, we notice that the b is always the base. It'll stay the same. Again, that's why the bases have to remain the same. And then I have a 6 and a 4. So if I take 6 and 4 and I want to make it 2, what do I need to do? What operation do I need to perform? And that does happen to be subtraction. So the base is the same, but we're going to actually subtract 6 minus 4 is a shortcut, and I can get b squared. And that will lead us to our general formula for this, where if I have a to the m divided by a to the n, or as a fraction, we have a to the m divided by a to the n. That is going to equal a m minus n. And that works with any numbers. I can have 5 to like the 25th power. Now that's a pretty big number. Then I want to divide it by 5 to the 7th power. I mean, it's going to take a long time to write out 25 5s. So I just simply go 5, and then I do 25 minus 7. So that is equivalent to 5 to the 18th power.